Have you ever seen a rainbow? If you have, you'll know that it needs to be raining for us to see one, right? But what if I told you you can actually see one when it's not raining? Let me show you what I mean. Now, the first thing that's required to see a rainbow is the sun. And the sun is out over there. The second thing is a source of water. In most cases, it's the rain. It's not raining now, but we have a fountain. And the fountain can play the role of the rain. So if we look at it from the right direction, we should be able to see a rainbow. Let's check. You see that? You can actually see a rainbow just as predicted. You can see all the 7 colors in the shape of a nice bow. Beautiful, isn't it? Now, to understand how this is happening, look at where I'm standing. The sun is over there, I'm here, and the fountain is in front of me. And this is important. So, to understand how rainbows work, we first need to look at how sunlight interacts with raindrops. Now, if you take rain and if you take an individual raindrop, it will look like this in the shape of a teardrop. But then, for all practical purposes, we can approximate it to be the shape of a sphere. All right? Okay, now, let's say I had a large spherical droplet of water over here. And for the sake of simplicity, let's say I have an incident ray at some random angle like this. And also let's assume that this incident ray is of red color. It's red in color, okay? Now what would happen? Now this ray is traveling from air to water, which means that it will bend toward the normal, right? That's simple, so it will refract. Now if you follow that refracted ray, it will reach the other side and it will reach an interface where it's moving from water to air. So therefore it will refract again. But then, I'm not concerned about that. I'm concerned about another phenomenon that takes place over there. It's called partial internal reflection. So most of the light will get refracted and some of the light will also get partially reflected back inside. So let's follow that reflected ray. So we follow the reflected ray over here, then this ray reaches another interface where it's moving from water to air, right? Therefore, it's going to get refracted again, right, in such a way that it will bend away from the normal. So, of course, there is partial internal reflection that takes place over here, but we're not worried about that. I'm only worried about the refraction in this case. So there are 3 important phenomena that we need to be worried about or concerned about. The first is refraction, then partial internal reflection, then refraction again. Okay? Now, the interesting thing is, if I had a bunch of, let's say, parallel red rays, all incident at the same angle over here, there will be multiple refracted rays and multiple emergent rays that come out in the side. But it's interesting to note that at an angle of 42 degrees, the intensity of these rays will be maximum. I repeat, at an angle of 42 degrees with the incident rays, the intensity of the emergent rays will be maximum. So for all practical purposes, we can assume that all the light is coming out at 42 degrees. So if I had a bunch of rays of red color incident at this angle, then the emergent rays will all come out at 42 degrees. Now instead of red light, if I had violet light, right, I had a ray of violet light that's incident at the same angle, what would happen? Well, we all know that the refractive index of a medium is different for different colors. So therefore, the angle of refraction will be different, right? So it'll bend at a different angle, it'll come out at a different angle, and therefore the final emergent ray will also be at a different angle, right? But what's interesting to note is that the maximum intensity occurs at 40 degrees for the case of violet light. So if I had a bunch of parallel violet rays all incident at this angle, the final emergent ray will be at an angle of 40 degrees. So the angle of deviation, you can call this angle the angle of deviation, is basically, okay, let's call it delta. This angle is delta, and the delta for violet light we find experimentally is about 40 degrees. So 42 degrees for red light and 40 degrees for violet light. And of course, I mean, it's pretty easy to understand that the angle, the delta for all the other colors, right, the colors between violet and red will all be in between 42 and 40. So then you should be able to answer what will happen if instead of violet or red, I had a ray of white light or a bunch of rays of white light incident at this angle. You'll find that all these rays split up, come out, and then finally we have red light coming out at 42 degrees, violet light coming out at 40 degrees, and all the other colors, indigo, blue, green, yellow, orange, and red, all of them in between. Now comes the beauty of the sphere, because the sphere is symmetric in all directions. What I mean is, if instead of having a single ray of red light at some random angle like this, let's say I had it coming in horizontally like this, then the emergent ray will come out at an angle of 42 degrees. This we know. But then it will symmetrically come out above as well, right? There'll be another ray that comes out at an angle of 42 degrees. Now, if you think about it, these two will not be the only rays. There'll be infinitely many rays, right? Because there are infinitely many planes in which this will happen. So if I turn this sphere like this, in every single case, there'll be an angle, there'll be a ray that's coming out at an angle of 42 degrees. So if I look at it from the front, you'll notice that there'll be a cone of light. There'll be a cone of light, red light, that's coming out at an angle of 42 degrees, right? To give you a better idea of what I mean, let's do a simple thought experiment. Let's say I had a dark room with a hole in one of the walls, and then I have a spherical droplet of water that's suspended in the path of that hole inside this room. Now I shine a ray of red light, which is incident on this droplet of water. Just like I showed, there will be multiple rays, infinitely many rays that are all coming out at an angle of 42 degrees, which will form a cone of red light. So if I looked at that front wall from this side, you'll notice that it'll form a circle of red light on that wall. Now, into this same room with that water droplet, if instead of red light, I shone, let's say, violet light, then what would happen? Well, we know that in the case of violet light, when it interacts with the spherical droplet of water, the light comes out, or the emergent rays come out at an angle of 40 degrees, right? Which means that this cone, it'll also produce a cone of violet light. The only difference being that violet light will come out at an angle of 40 degrees. So if I looked at the front wall from behind, I'll see a smaller circle of violet light, right? Now, let's make it slightly more interesting. Instead of violet light, let's say I shine white light. Now what will happen? Now we know that white light is a mixture of all the 7 colors, right? When this violet light hits this water droplet, the red light and the violet light and all the colors will split up, and finally it will give off a cone of red light, violet light, and all the other colors in between as well. So what I'll end up seeing on the front wall from behind will be multiple circles. There'll be a red circle, then all the other colors, and then finally a violet circle. So now that we have a very clear idea about what happens when white light is incident on a spherical drop of water, let's go outside and see how a rainbow is formed. So right now, the conditions are just perfect for us to see a rainbow. If you look closely, the sun is behind me over there, and it's raining in front of me over there. Okay, so let's first freeze the water droplets, okay? And let's consider just one column of water. And I'm going to pick one droplet in that column of water. Now we know that sunlight is white light. It's going to come from the sun, it's going to be white in color, and all the rays are going to be incident, and all the rays are going to be parallel because the sun is very far away, okay? Now, consider when you take one droplet, sunlight is hitting it, and then we know that it's going to give off red light at 42 degree angle and violet light at a 40 degree angle and all the other colors in between, right? But in this case, none of that light is reaching me, so it's Nothing special. So to me, that droplet is going to look like water, right? Nothing special. If I take the one below it, even then, none of the light is reaching me, so it's still going to look just like water. But then, if I keep going lower and lower, at one point, the position of the droplet is such that sunlight hits it, the light comes off, say red light comes off at an angle of 42 degrees, and that red ray reaches my eye. Now what will I see? Now because my brain is receiving red light from that droplet, my brain is going to tell me that that droplet is red in color, right? Okay, cool. So to me, that droplet is going to appear red. Now as we keep going down a little further, you'll notice that there will be a little droplet lower that will give off violet light at a 40-degree angle, and that ray reaches my eye. So therefore, to me, that droplet is going to appear violet in color, right? Now similarly, if you consider the droplets in between, let's say the one just above the violet droplet, the ray that's coming off will be slightly greater than 40 degrees. So you can say that that droplet will appear indigo to me, right? So as you keep doing that, you'll find that all the droplets in between will appear violet, indigo, blue, green, yellow, orange, and then finally red. So that set of droplets will appear in these colors. And if you keep going further, they will, again, none of those rays will reach my eyes, so therefore they will appear normal. They just appear transparent or, just like water, right? Now, there is another way to figure out which droplet will be red and which droplet will be violet. Now, come back to me. Over here, because the sun is over there, I'm going to form a shadow somewhere over here, right? And if I draw a line from the top of my head to the top of my shadow, let's call it the shadow line, this line is going to be parallel to the rays from the sun, right? Because the sun is so far away that we can assume all the rays from the sun are parallel to each other. And this line will obviously be parallel to all the rest of the rays, right? Okay. Now go back to the droplet, the red droplet, right? Now the sun's rays hits it, and then it gives off a droplet, it gives off a ray of red light at an angle of 42 degrees, which reaches my eye. Now, if you look at this shadow line and the ray from the sun that's hitting the droplet, we know that these two lines are parallel, right? And this ray of red light basically cuts two parallel lines, which means that if the angle that makes with the ray of light is 42 degrees, then the angle that this ray makes with the shadow line should also be 42 degrees, right? Because they are interior opposite angles, correct? So another way of figuring out which droplet will be red will be just to draw my shadow line and draw a line that's at an angle of 42 degrees with the shadow line and find where it intersects. So if the droplet that this line intersects will be red in color, correct? Similarly, I can do it for violet as well. Now, the only thing is I just have to change the angle to 40 degrees. So I draw my shadow line, I find a line that makes an angle of 40 degrees with this shadow line, and find the droplet that this line intersects. That line, or that droplet, has to be violet in color, correct? And the other droplets, the other colors, will just be at angles between 40 and 42. As I keep increasing the angle, then I will get different droplets in different colors: violet, indigo, blue, green, yellow, orange, and then finally red. Now let's bring back all the other droplets. If I draw a line that's making an angle of 42 degrees with my shadow line, you'll notice that there are multiple other droplets on this line, right? Which means that all of these droplets will also be sending red light to my eyes. Therefore, they will also appear red to me, okay? Now if I draw another line that's making an angle of 40 degrees with my shadow line, then all the droplets on this line will also appear violet to me, correct? So if I draw other lines making angles between 40 and 42, then the droplets on those lines will respectively appear indigo, blue, green, yellow, and orange, right? But that's not all. What if I draw another line like this? in such a way that this line also makes an angle of 42 degrees with my shadow line. Because there's not just one line that makes an angle of 42 degrees with my shadow line, right? This line also makes an angle of 42 degrees with my shadow line, which means that the droplets on this line will also appear red to me. But wait a minute, I can draw another line in this direction as well, right? That line will also make an angle of 42 degrees with my shadow line. If I think about it, I can draw infinitely many such lines, and all of them will make an angle of 42 degrees. So there'll be a cone that subtends an angle of 42 degrees at my shadow line, and all the droplets on this cone will appear red to me. Similarly, if I consider a cone that subtends an angle of 40 degrees at my shadow line, then all the droplets on that cone will appear violet to me, right? And of course, the cones that subtend angles in between those will be of the respective different colors. So if you look at it from my perspective, you will end up seeing semicircles, right? Different semicircles of different radii. Now, the outermost semicircle will be subtending an angle of 42 degrees at my shadow line and will be red in color. The innermost semicircle will subtend an angle of 40 degrees and will be violet. And the semicircles in between will be the other colors, indigo, blue, green, yellow, and orange, right? So this is the rainbow. So the reason we see the rainbow is because all these infinitely many droplets are individually interacting with sunlight. They all give off different colors at different angles. And depending on the angle that they subtend at our eye, they appear a particular color. Beautiful, isn't it? And this is also the reason why we saw the rainbow in the fountain. If you remember, I was standing at the right position. The sun was behind me and the fountain was in front of me. And the droplets that appeared red were making an angle of 42 degrees or subtending an angle of 42 degrees at my eye.